exercise 5.4 question number 1. Find the equations of two tangents that can be drawn from 5, 2. So this is a point 5, 2 from which we are drawing two tangents. The question is to find the equation of the two tangents given the ellipse equation. My very first step, try to write the ellipse in standard form. What do you mean by standard form? Standard form tells me the right hand side must be 1. So whatever number comes in right hand side, divide. 14, I am dividing every term. This gives rise to x square by 7 plus y square by 2 equals to 1. Comparing with x square by a square plus y square by b square equals to 1, I get a square is 7 and b square is 2. The given point 5, 2, treat it as x1, y1. Now, what is the condition? How to do it? Y equal to mx plus c be the tangent. And what is the formula? C is equal to a square m square plus b square the whole square root. So how will I write y? Mx plus root of a square. What is a square in this question? 7. M is not given, right as it is. B square is 2. So 7m square plus 2. This is the tangent equation. From which point? 5, 2. So tangent is through the point 5, 2. What do you mean by passing through? It must satisfy the equation. So wherever x and y are coming, put 5, 2. 2 equals 5m plus or even minus. Whenever I put square root, put plus or minus. Root of 7m square plus 2. Bringing 5m to the left side, 2 minus 5m is plus or minus root of 7m square plus 2. Whenever square root is there, keep square root alone in one side and square on both the sides. When I square, root and square will get cancelled. That is our main idea in mathematics. Try to keep square root alone in one side so that squaring will remove the square root symbol. What about the left hand side? It is a minus b the whole square. So when I square, it is a square plus b square minus 2 into 2 into 5m. That is 20m equals to, as I square, square root and square gets cancelled, 7m square plus 2. Now let me bring all the terms to the same side. As I bring all the terms to the same side and simplify, we get 9m square minus 10m plus 1 equal to 0. Factorize. 9 into 1, 9. And I need minus 10. So what are the two numbers? Minus 9, minus 1. Minus into minus plus, 9 ones are 9. Minus 9 minus 1 gives rise to minus 10. Here the first term is 9m square. So divide by 9m and try to simplify. I get m minus 1, m minus 1 into 9m minus 1 equals to 0, or m is equal to 1 or m is equal to 1 by 9. Put m value back in this equation. Call this as number 1 and we get the two different tangents. Put m is equal to 1. I get y equals to x plus or minus root of 7 plus 2, or y equals to 7 plus 2, 9, square root is 3. This is one equation. Put m is equal to 1 by 9. As I put 1 by 9, it is y equal to 1 by 9x plus or minus root of 7, 1 by 81 plus 2. Simplify this answer. It is x by 9 plus or minus 162 plus 7, 169 by 81 square root, or y equal to x by 9 plus or minus 13 by 9. Cross multiplying, 9y equals x plus or minus 13. So we are able to achieve two different equations. Y equals x plus or minus 3, or 9y equals x plus or minus 13, and that is the answer. So in this problem, the major formula that we remember, keeping y equals to mx plus c to be the tangent, c equal to root of a square m square plus b square. Get a square b square from the equation and substitute the point, solve the equation, get m value, put it back in this equation 1. Try to get the two different tangents. Exercise 5.4, question number 2. Find the equations of tangents to the hyperbola parallel to a line. Hyperbola, let us compare with the standard form. X square by a square minus y square by b square equal to 1. Comparing with x square by 16 minus y square by 64 equal to 1. This tells me a square equals 16 and b square equals 64. This line 10x minus 3y plus 9 equal to 0. What is the slope? Minus coefficient of x by coefficient of y, that is minus 10 by minus 3, or I will say m is equal to minus 10 by minus 3, that is 10 by 3. So I am able to find out a square, b square, and the line is parallel, tells me parallel lines have same slope. So the tangent also has the same slope m. So parallel lines tell me the tangent and the given line have the same slope. What is the equation of tangent? Y equals mx plus or minus root of a square m square minus b square. If it is ellipse, plus symbol, and if it is hyperbola, we have minus symbol. Let us substitute all that we know. Y equals mx 10 by 3x plus or minus root of a square 16 m square 100 by 9 squaring this minus b square is 64. This is y equals 10 by 3x plus or minus root of 1600 minus 9 into 64, the whole thing divided by 9. As I simplify, it is y is equal to 10x by 3 plus or minus root of 1600 minus 576 is 1024 by 9. And we know the square root. Y equals 10x by 3 plus or minus 32 by 3. Square roots, cross multiplying, 3y equals 10x plus or minus 32, or bringing all the terms to the same side, 10x minus 3y plus or minus 32 equal to 0, or the equation of tangents. So how many tangents we have found out? Two tangents for the hyperbola parallel to the given line. So check, parallel lines will have same coefficients, 10x, 10x, minus 3y, minus 3y. They change only with the constant. Exercise 5.4, question number 3. Show that the line is a tangent to the ellipse. Also, find the coordinates of the point of contact. From the line x minus y plus 4 equal to 0, identify what is m and c. For which, let us rearrange. Y equals to x plus 4, bringing the terms to the other side. Compare with y equals to mx plus c. So it tells me m equals 1 and c equals 4. Then go on to the ellipse equation, x square plus 3y square equal to 12. In all the ellipse equation, I want to retain 1 in the right. So, divide by 12. X square by 12 plus 3y square by 12 equals 12 by 12. Cancelling, we arrive at the standard form. Compare this with x square by a square plus y square by b square equal to 1, which gives rise to a square is 12 and b square is 4. Having known c, m, a square and b square, what is the condition for tangency? A line is a tangent to the ellipse if c is equal to root of a square m square plus b square. Let us find out whether this condition is satisfied. So c equals to 4. Let me find out the RHS, that is root of a square m square plus b square. Or I get root of 12 into 1 plus 4. 12 plus 4, 16. 16 square root is 4. So we are able to arrive c square is equal to a square m square plus b square, implies the given line is a tangent. So I am able to say the given line is a tangent provided this condition c square equals a square m square plus b square is satisfied. Now the second part of the question, point of contact. The formula is a square m by c comma b square by c. For hyperbola and ellipse, let us remember first coordinate is always negative. For ellipse, it is plus b square by c. For hyperbola, it is minus b square by c. So what is the point of contact? For the ellipse, minus a square m by c plus b square by c. As I substitute, a square is 12, m is 1 by c value 4. B square is 4 and c value is also 4. This gives rise to minus 3 comma 1. So we are able to show the given line is a tangent and the point of contact is minus 3 comma 1. Exercise 5.4, question number 4. Find the equation of tangent to the parabola perpendicular to the line given. How to find out slope of this line? Slope of 2x plus 2y plus 3 equal to 0 is minus coefficient of x by coefficient of y, which is minus 2 by 2 and that is minus 1. Given the tangent is perpendicular to this line. So call this as number 1. So tangent is perpendicular to 1 tells me m is equal to minus reciprocal. So perpendicular lines tell me m1, m2 is minus 1 or slope of the perpendicular is minus reciprocal. So minus 1 by minus 1 tells me it is plus 1. Once I know m, I need to know what is a from the parabola. So y square equal to 16x is the parabola given. Let us compare with the standard equation y square equals to 4ax. This tells me 4a is 16 or a is equal to 4. Having known a and m, we need to write the equation of the tangent. And the formula for the tangent is y is equal to mx plus c. C is equal to a by m. A value is 4 and m value is 1. So thus gives rise to 4. Y equals mx plus c. M is 1 plus c value is 4 and this is the equation of the required tangent. Or bring everything to the same side. X minus y plus 4 equal to 0. Exercise 5.4, question number 5. Find the equation of tangent at t equals 2 to the parabola. Parabola equation y square equal to 8x. Compare with y square equals to 4ax. 4a is 8 implies a is equal to 2. Tangent at t. We should remember the formula. It is yt equals x plus at square. T value given as 2 in the question. Just substitute. Y into 2 equals x plus a value 2. T square is 2 square. Simplifying, 2y equals x plus 8 or x minus 2y plus 8 equals to 0. Second method. First method is very simple, but we need to remember the formula. The second method, we can take the point at square comma 2at as x1 comma y1. What is a? A is 2 and t is 2. So a is 2 and t square is 4 comma 2 into t value 2, or I get 8 comma 8. Once I know x1 y1, what is the parabola given? Y square equal to 8x. So is the parabola given. How to write the tangent? Tangent to any curve, I can write y square becomes y1 and x will become x plus x1 by 2. This technique we can use not only for parabola but for all the curves in two-dimensional geometry. So tangent I can write y square will become y1, constants or coefficients as it is, x becomes x plus x1 by 2. Now wherever x1, y1 comes, put 8 and 8. So this will give rise to y into 8 equals 8 by 2 into x plus 8. 8 and 8 cancels, cross multiplying. 2y equals x plus 8 or x minus 2y plus 8 is equal to 0. Both the cases we arrive at same equation. Here I must remember the tangent formula. Here if I remember this parametric representation, I can find out x1, y1 and proceed on to the tangent. Both are correct. Proceed with any one method, whichever you are comfortable. Exercise 5.4, question number 6. Find the equation of tangent and normal to the hyperbola at theta equals pi by 3. The hyperbola equation, right hand side must be 1, so divide by 108. Comparing with x square by a square minus y square by b square equal to 1, I get a square is 9 and b square is 12. Once I know a square and b square, what is a? That is 3. What is b? It is square root of 12. 12 is 4 into 3. That is 2 root 3. Once I know a and b, how to write the point x1 comma y1? The formula for hyperbola is a secant theta comma b tan theta whenever theta is given. Theta is pi by 3. So let us substitute. A value 3 secant pi by 3, b value 2 root 3 tan pi by 3. And we know secant pi by 3 is 2, cos 60 is half, secant 60 is 2. 2 root 3 into tan pi by 3 is root 3. Simplifying, we get 6 comma 6. Once I know the point 6 comma 6, how to write the tangent? Tangent for 12x square minus 9y square equal to 108 at 6 comma 6 is 12. X square becomes xx1 minus 9. Y square becomes yy1, constant as it is. Wherever x1, y1 are coming, put 6 comma 6. 12x into 6 minus 9y into 6 equals 108. Reducing, we get the answer. Dividing by 6, we arrive at 12x minus 9y equals 18. Further, divide by 3, it is 4x minus 3y equals to 6. Or I can say 4x minus 3y minus 6 is equal to 0. Now, we need to proceed to the normal. A curve is there and a tangent cuts like this way. So, this is a tangent. Normal is a line perpendicular to the tangent at the point 6, 6. So, normal equation will be, when I say it is perpendicular to the tangent, interchange the coefficients. So, normal equation is 3x 4y. 3 goes to x, 4 goes to y. This minus comes, change it as plus, because we know m1, m2 equal to minus 1. So, this formula makes us to write like this. X coefficient to y, y coefficient to x, and constant also we need to change. How to find the constant? Normal also passes through 6, 6 only. So, wherever x, y are coming, put 6, 6. 3 into 6 plus 4 into 6 plus k equals to 0, or 18 plus 24 plus k 0, or k is equal to minus 42. Putting it back in normal equation, we get the normal equation 3x plus 4y minus 42 equals to 0, and in this problem we have derived the tangent equation, also the normal equation. So let us take and write both as the answer. Tangent equation is 4x minus 3y minus 6 is equal to 0. Exercise 5.4, question number 7. Prove that the point of intersection of tangents at T1 and T2 to the parabola is a T1 T2, a T1 plus T2. So here we have drawn a tangent at T1 and another tangent at T2. So at T1 there is a tangent, at T2 there is a tangent. When they intersect, find the point of it. So we must remember at T1 and T2 how to write the equation of the tangent. Once I have written the two tangents, the second step is to solve, because whenever we come across point of intersection, solve the two equations. As we subtract, 1 minus 2 gives me yt1 minus yt2 equal to x minus x cancels, at1 square minus at2 square. Here y is common, t1 minus t2. Here a is common, t1 square minus t2 square, which can be further written as t1 minus t2 into t1 plus T2. This is a square minus b square formula, which gives rise to a plus b into a minus b. The LHS y into T1 minus T2. We can cancel T1 minus T2 because it is not 0. T1 and T2 are not equal. So I can cancel. I get y equals a into T1 plus T2. Put y value back in first or second equation. Substituting y equals a into T1 plus T2 in equation number 1. Y a T1 plus T2 into T1 equals x plus a T1 square, or x is equal to a T1 into T1 T1 square plus a T2 into T1. So A T1 T2, bringing A T1 square to the left side minus A T1 square. As I cancel these two, we get x is equal to A T1 T2. So the point of intersection of the two tangents at T1 and T2 is A T1 T2 and A T1 plus T2, x value, y value. Even though it is a theoretical question, it's a very simple problem wherein we must remember the equation of tangent at T. So in the place of T, I put T1, I put T2. I get the two equations. Solving. It's a very simple solving which gives rise to A T1 T2 and A T1 plus T2. Exercise 5.4, question number 8. If the normal at T1 on the parabola meets it again at T2. We have drawn a tangent at T1 and this is a normal, a line perpendicular to the tangent. This normal meets the curve again at T2. Then we need to show some condition. We need to remember the equation of normal at T1 formula. Equation of normal at T1 is y plus xt1 equals 2at1 plus at1 cube. Given it passes through T2. What is T2 actually? We say at T2, but the point is at2 square comma 2at2. Shortly we call T2, but the meaning is x value at2 square and y value 2at2. When I say normal passes through, this must satisfy the equation. So wherever x comes, put at2 square, and wherever y comes, put 2at2. So we get 2at2 plus x value at2 square T1 equals 2at1 plus at1 cube. As we try to simplify, 2at2 minus 2at1 equals to at1 cube minus at2 square T1. In these two, 2a is common. If I take it out, T2 minus T1. In these two, a T1 is common. If I take it out, T1 square minus T2 square. Now a and a gets cancelled. I can take minus sign out. Minus 2 into T1 minus T2 equals T1 into, this is a square minus b square formula. So it is a1 a plus b into a minus b. Again we can cancel T1 minus T2 because they are not equal. So I can very well cancel. I am left with minus 2 equals T1 into T1 plus T2. Or I can say minus 2 divided by T1 equals T1 plus T2. Or this further tells me T2 equals minus 2 by T1 minus T1. Or taking minus symbol as common out, T1 plus 2 by T1, and that is the result to be shown. So we have shown T2 equals minus of T1 plus 2 by T1. This is also a simple problem provided we are able to remember this formula. Equation of normal at T1 is y plus xt1 equals 2at1 plus at1 cube. Wherever x and y are coming, meets again at T2 tells me substitute at2 squared comma 2at2. As we simplify, we arrive at the given result.